features. In the specific identification process, there are several issues that greatly affect the effect. There has 3 points. First is occurring result in the loss of some feature. And the next is different perspective and elimination lead to different characteristic of the same target. Last is close with similar colors. Our future for different targets will result in reduced the differentiation. So we have a problem. Then we should have some solution. Based on the above 3 problems, many solutions have been proposed, mainly focusing on the following aspects. One is extraction is more suitable for characterizing human features, such as LBP, Garble feature, and CNN, so on. Second is choose an appropriate distance measure function for Mahaneber's distance. 3. Pathmeter chain such as SGD, Adam our spatial mapping results in smaller inter-class distance and larger inter-class distance. Next, content mainly about CNN. Convolution neural network is a kind of deepening and has become a research hotspot in the field of image understanding. It is a way to share the network structure, making it more similar to a biological neural network, reducing the complexity of the network model and the number of weights. This advantage is more evident when multidimensional images are input to the network. Images can be directly used as input to the network, avoiding complex feature structure and data reconstruction processes in traditional recognition algorithms. CNN was proposed by Mr. Ian Lachlan of New York University. CNN is essentially a multi-layer perception machine. The key to it is success lies in the way it connects locally and shares weight. On the one hand, the number of weight reduced makes a network easy to optimize. On the other hand, it reduces the risk of overfitting. CNN is one of the neural networks. It is a way to share the structure of the network, making it more similar to a biological neural network, reducing the complexity of the network model and the number of weights. This advantage is more obvious when the input of the network is a multi-dimensional image. So that the image can be directly used as the input of the network. There are many advantages in two-dimensional imaging processing, such as the network can extract image feature including color, texture, shape, and imagine topology by itself. It has good robustness and computational effects in dealing with two-dimensional imaging problems, especially in identifying displacement, scoring, and other forms of this distortion invariancy applications. And CNN has some advantages that traditional technology does not have. Good filter tolerance, parallel processing ability, and self-learning ability. Can be handle complex environmental information, unclear background knowledge, unclear inference rules, allow symbols to have larger defects. Discern fast operation, good adaptive performance, and high resolution. It combines feature extraction into a multi-layer scenario by extraction and reducing weight, eliminating the complex imaging feature extraction process before recognition. The generalization ability of CNN is significantly better than other methods. Convolutional neural network CNN have been applied to partner classification, object detection, and object recognition. The CNN is used to build a partner classifier, and the CNN is used as a general partner classifier for Glasgow imaging directly, and it is for wide cross-processing network which can extract its topology from a two-dimensional image and optimize the network structure by using a backpropagation algorithm to solve unknown parameter in the network. CNN is a kind of multi-layer network specially designed to process two-dimensional data, and it is considered to be the first truly successful robust in deep learning method using a multi-layer network. And it reduces the number of trainable parameters in the network by meaning spatial correlation in the data to improve the efficiency of the forward propagation networks backup propagation algorithm, which is also considered a deep learning method because it requires very little data processing. In a CNN, small errors in an emoji are used as input data at the bottom of a hierarchy, and information is propagated forward through our layer of the network. Each of which is composed of filters, so that some significant features of the observed data can be obtained because locally perceived errors can occur some basic features, such as borders and corner in an image. This method can provide a degree of relative invariance to displacement, traction, and rotation. The close relationship between layers and spatial information in CNN make it exactly suitable for imaging processing and understanding, and can automatically extract rich light feature from images. And it is make full use of the local collector contained in the data itself by combining local perception error shared with spatial or temporal downsampling optimizes the network structure and ensure a certain degree of displacement and distortion invariance. Inspired by the Vasio narrow machine learning, CNN is a multi-layer signal designed to recognize 2-hour three-dimensional signal. This network structure is highly invariant to translation, scoring, teaching, and other distortions. CNN can be used identification to our three-dimensional imagine of displacement, scoring, and other form of distortion invariance. Next, the narrow of the same feature graph share weight, which reduce network parameters, which is also a major advantage of convolution network over few connected networks. Sharing local weight a spatial structure closer to the true biology neural network make CNN have unique advantages in imaging processing and speech recognition. On the other hand, it should reduce the complexity of the network and multidimensional input signal can be directly input the characteristic of the network to avoid the process of data during future extraction and classification. Also, CNN is a special deep neural network model. It is popularity is reflected into aspects. First is the connections of its neurons are not full connected. Second is the weight of the connection between some neurons in the same layer are shared. It is non-flow connected and view-sharing network structure makes it more like a biology neural network, reduce the complexity of the network model, and reduce the number of weights. CNN is a machine learning model under deep supervised learning. It has a strong adaptability. It is good at meaning local feature of data, extracting global team feature and classification. Its weight sharing structure network makes it more similar to biology neural network and has achieved good results in various fields of partner recognition. CNNs typically use alternating layer of convolution and sampling on one layer after another of sampling followed by one layer of convolution, so that the convolution layer extracts the features, then combines them two from more abstract features, and finally from the descriptive feature of the picture object. The most important feature of CNN are sphere connection and view sharing. Spheres connection and view sharing can be reduce the parameters to be trained and the computational complexity. And the next part is CNN structure. Today just have partly. CNN is a multi-layer supervised learning neural network. The convolution layer and the pore sampling layer of hidden layer are the core modules to realize the future extraction function of CNN. The network model inverts the weight parameters in the network layer by minimizing the loss function using a gradient descent method and improve the accuracy of the neural network through frequent interaction chain. The low head layer of convolution neural network is composed of convolution layer and maximum pore sampling layer alternately. And the high layer is the head layer corresponding to the traditional melt layer perceptor and the logistic regression classifier. The input of the first few connected layer is a future imaging derived from the features of the convolution layer and the subsampling layer. The last output layer is a classifier that can use acoustic regression. Okay, that's all. Thank you.
Okay. Okay, Hun, thank you very, very much. I think it is good. And let's start discuss. Please, do you have any question for Hun?
No, I don't have any. But I guess that today we need to discuss how we can plot some convolutional neural network in PyTorch maybe, and after this, I'll get you some tasks for the next week. Yeah.
Yes, yes. I don't have questions, but I have one note. I think you should include in your report some results with methodology which you use in your practical work. Okay. Do you understand me?
Particle work?
Yes, yes. You have a task from Vasily. Yes.
Yeah, maybe you can add some information about UTK phases, maybe about data sets and some information about data sets. Yeah, now you have a report just in common words. Yeah, in common words about some scientific topic which is connected with convolutional neural network, but it will be better if you will have some information about, for example, phases, data sets,
Yes, yes. It is second part. It is second part materials and methods. Yes, about data sets, about any materials and any methods which you use.
For instance, Kun, it will be better. It will be best if you try to find any data sets with phases, and just get some analysis about these data sets, which phases, which features these data sets have. These data sets have, and other interesting things which can help you use these data sets for your scientific research. For instance, just now I previously got you some information about UTK phases data sets, and you can describe these data sets and try to find other data sets with phases, for example, in person. Yeah. So.
Okay. Do you understand this idea?
You understand. You mean that I need to add some information about my special task.
Yeah, yes, of course, because it is just a small step about your scientific research, because you need to find data sets, maybe some open data sets with phases for continue your study. Yeah. So, and maybe it will be interesting things if you find any data and conduct some analysis of this data. Yeah.
Yes, and I think you should describe these materials in your report. Okay.
Yeah. Mm-hmm.
Okay, understand. Thank you very much.
Okay. Any question for Hun or not? Maybe. Okay. Okay. I think fine, and I think we can and we can go next step. Maybe Mohammed. Can you show your
Yeah,
report?
can I present this week because last week I didn't attend, so I um, I didn't prepare well this topic.
Unfortunately, and when you prepare your report?
I can present it next week.
Okay. You should prepare two tasks. Okay, to this week and to next week. Okay.
Yes.
Okay. Understand. And okay, Ali.
Yes, Professor, I am ready.
Okay. Ali, please start. Show your screen.
Sure. Okay, can see my screen?
Yes, all fine.
Okay. The report today about the basics of image processing and finding age, gender, and race. First, introduction. Today is world is full of today and image from a significant part of his data. However, before they can be used, the digital image must be processed, analyzed, and manipulated in order to improve the quality or extract some information that can be put to use. Computer store images as a mosque of tiny squares. This is like the ancient art form of till mouse, or the melting bed kids play with today. Now, if this square tiles are too big, it's done hard to make some smooth edge and curves. The more and similar tiles we use, the some other, or as we say, less pixelated image will be. This sometimes get referred to our resolution of the image. Vector graphics are somewhat different methods of strong image that aims to avoid pixel related access. But even vector images in the end are displayed as a mosaic of pixel. The word pixel means a picture element. A sample way to describe each pixel is using a combination of their colors, namely red, green, blue. This is what we call an RGB image. And this figure explain about what do you see. And in RGB image, each pixel is represented by their 8-bit numbers associated with the values for red, green, blue, respectively. Eventually, using a magnifying class, if we zoom a picture, we'll see the picture is made up of tiny dots of little light, or more specifically the pixel. And what more interesting is to see the how this tiny dots of little light are actually multiple tiny dots of little light of different colors, which are nothing but red, green, blue channels. Every photograph in digital from is made use of pixels. They are the smallest unit of information that makes up a picture, usually round or square. They are typically arranged in a two-dimension grid. I am short my my paper and my word because time, and explain now about workshop, my workshop. Two, importing image. First, to workshop usually importing image. This importing image, now let's load the image and observe it version properties in general. This code improved library image, and this picture output in a quickly after that after this word will be I show my workshop to explain more. Now observer basic properties of image. If we calculate the size of RGB image to total size will be counted as height x with x3. On this code, this code about print information in picture for image height and image width. Next, this value is important to wirefully science to the 8-bit colors entity is cannot be outside of the 0 to 255 range. And this is very important from image. This code explain print image size. Now here we are also upload to change to number of RGB values as an example. let's see to the red, green, blue layers for following rows values to full intensity. First, red channel range 100 to 110, and J 200 to 210, and P 300 to 310. On this code explain about range and this name is my name file. Next, splitting layers, splitting the image into separate color components is just a matter of filling out the correct select of the image array. Now import NumPy as NP. This library very important from image process, and this code explain about what are this picture and point, explain grid zero matrix and sense H channel and display H channel and output in my workshop. Now image data analysis using NumPy, OpenCV, detecting high pixel of H channel, one only red pixel value higher than 118, and two only green pixel value, and three blue, and four compositive mask using local AND. Now I speak about the UTK face dataset. Is a large dataset composite of over 20,000 face image with their respective annotations of age, gender, and ethnicity. These images are properly cropped into the face region, but display some version in post elimination resolution. And now explain about what age and gender and race. Age is an integer from 0 to 116. And gender is an integer with which 0 represent male and 1 represent female. And now race is an integer from 0 to 4. Like African, Asian, dating with Black, Asian, Indian, and others respectively. And data and time, don't think we when the picture was taken. Now, finding age, gender, and race, but this not exactly to find, but I show this code in Jethep. Let's start be important some libraries and greeting our dictionary to help use on parsing the information from the dataset along with some other information. Dataset location, training, simulate width and height of the symbols. And this code, this code from library and this name file. This name file to continue in last lecture I am using. Now dataset in white from 0 for 0 to 4, 0 white, 1 black, 2 ASEAN, 3 Indian for others. Gender 0, 1. And now dataset dict and gender alleles. An output also in my workshop. Now let's define a function to help use on extracting the data from our data set. This function will be used to attest over each file of the UTK dataset and return a pandas data frame containing all the field, age, gender, and race. Rest. No sex. Now this code define in file name. Continue from all this code. I mean file name equal os.path siblet path 1 or 0. This from defined this file and age, gender, and race. This output in this code, age and gender and race, and file data. For example, when you have age 0, 50 years in gender. Sorry, age.
Yeah, I guess that there is some problems here. Yeah.
Yes.
Column, but,
yes. Yes, but in the workshop, good. Now, conclusion. The papers has reviews the basic of image processing and finding age, gender, and race. Facial analysis has gains much recognition in the computer's vision community in the recent past. Humans faces connection features that detriment identity, gender, emission, and the authenticity of people. And now the reference. I back to my workshop.
Thank you very much, Ali. Amazing. I
Yes.
think it is really good work.
Yeah, this
Thank
is
you.
great work.
Okay, I have one question. Could you describe the methodology which you use in your work in the form of a flow chart or maybe a block diagram?
Again, please.
Could you describe your methodology in future? Yes.
Yes.
Use include picture with a block diagram or maybe flow chart. I think
Yes.
it is a good way to describe your
Yes.
methodology.
Yes. I think in next week I using a notebook
Okay.
from codes. Now this my workshop. This library they change BGR to RGB because OpenCV directly open from BGR. From this, I needed to change to RGB. This defined show image from defined this, and now I show two picture BGR from change RGB and this importing image. Yes, I'm using this file. And quickly this I read this word this information about this about my picture like type of this image class image core util array and this shape of the image this number 720 yes and height and width and dimension of image and now print the image to explain image size, the size, and for using show the channel R or J maybe O or B. Where is O? Yes, because I am using last picture different. But now, yes, correct. On this range to channel, on this again to explain the RGB, this line, I am using this code because full intensity to this pixels are channel on this two line, on this three line to explain all this RGB to explain color. Now split layer using 3 to explain more, like grid 0 matrix using this code, and image data analysis using NumPy OpenCV, this code in JFib I am using now to explain what like filters about picture, and this information about my image, height 700 pixels and width 1920 pixel, and different layers. This in next lecture I return to write this code, but again for give it to change RGB because this picture.
Nice work.
And now some information about age and gender and race. This table explain. I am using this file part 1 properties. This to continue, and this added library, and this explain about start by plotting the race distribution with our representative flow district method, and this from race, and this from gender, and this from histogram about age. and finish. Thank you.
Excellent work.
Yes, yes,
Yes.
really good work. Fine.
So
fine.
I guess that other students should do the same analysis of these data sets. Should get the same analysis because it is very important thing.
Yes. Thank you.
Hun and Mohammed, please note. It is really good work.
So because when you use such distribution, you can understand which people are include in these data sets. Means that you can see, for example, age distribution. You can see that a lot of younger people here. Yeah, a lot of
Yes.
2050 100. So and other people is less than young. Yeah, so maybe it is some disadvantages of these data sets because better if you use people with some average age. Yeah, here.
Yes.
But there are a lot of young people, and for this distribution, maybe it is okay because we have half people male and female, but just a bit more female, yeah. And if we look at race, yeah, race, I
Race.
guess, above. So there is a huge disbalance of classes. Disbalance because white people more than
Yes.
other classes, and this is not good. This is not good way for creating some models. If you try to, for instance, train some convolutional neural network for classification task, so this disbalance will be impact for these models, and of course you need to use this information and a bit change, maybe change loss function of your models and other. Okay, I guess that we discuss it, but of course previous pre-processing analysis and some analysis about datasets, it is necessary things for other steps for training model and for creating this model. Yeah, for example, for race classification. Yeah.
Yes.
So excellent work. Okay, it is very nice work.
Thank you very much.
No comments. So, and maybe today we meet with convolutional neural networks, and it will be the task for all of you. So I just show my screen. Yeah, can you see my screen?
Yes, I see.
So first of all, we start with handwritten digits classification, and we will meet with framework PyTorch. I prefer PyTorch to TensorFlow because TensorFlow is not good framework for me. I prefer Torch for its better performance maybe, and some simple idea of this framework. And today I just show you example how we can train the model for classification digits, handwritten digits, and of course you can use this approach for training model, for example, for classification gender. It is a good way. So and we start with analysis data sets. Yeah, what does mean handwritten digits data sets? Of course, we have the common data sets in Torch Vision. Torch Vision, it is some additional library for Torch, for PyTorch, Torch. So and here we can import our data sets MNIST. MNIST, it is a handwritten digits data sets here. And first of all, we determine some important things, but I guess that we will discuss it maybe in my my course computer vision, what they mean. Today, these parameters is not necessary for us. Maybe most important things, what does mean device? First of all, I guess you know that all convolutional neural networks train on GPU devices, and I recommend you to use GPU devices for training your model. And first of all, you should change your runtime type. I guess that default runtime is none. You can see that in Colab Google you can change this hardware accelerator like a GPU safe, and after this you will get sorry, maybe well, let's try again. Maybe I need to change my Are you hear me?
Yes, yes. Now better.
Now better.
Okay, nice.
Okay, please continue.
In runtime on the GPU, you can see that you have this command just show you all available run, and here you can see that Google allow you.
Excuse me, I don't hear you.
Vasily, do you hear us? We can't hear you.
Are you hear me now or not?
Yes, yes, now, yes.
And what's happened with my microphone, because here I have two microphones. Now is good or not?
Better. Please repeat last sentence.
In this command, NVIDIA SME, you will get information about all.
Now we can't hear you.
One moment.
Vasily, can you reconnect? Maybe restart.
And after some moments, you.
Yes, at this moment we can hear you.
Let's try again, maybe. Okay.
Okay. Thank you.
If we will have some problems, so I stopped and.
Big problem.
Yeah, we can't hear Vasily. Unfortunately. Okay, Vasily, can you reconnect maybe? I think it is. I hope maybe it is. Check it. Vasily, do you hear us? We can hear you. Can't.
Maybe go to change microphone.
Hello.
Hello.
Yes, hello. Now we can hear you.
I see that my Microsoft Teams is not good work in Linux, so sometimes.
Yes, Microsoft in Linux. Yeah.
Okay, let's try again. So now you hear me, yeah?
Yes.
So again, this command show you available devices, yeah, for training your neural network. And in PyTorch, you should determine which devices you use for training your neural network. And here, the simple string which check the number of devices, CUDA devices, because it is a NVIDIA GPU. And if there is some available devices, you can use these CUDA devices. Yeah, CUDA means GPU on NVIDIA chipset. Yeah, if there is no any CUDA devices, you should use CPU, but it is not a good way for training some big models. Yeah, big convolutional neural networks. So let's start, and you can see that now we determine devices. CUDA 0 devices means that 0 GPU. Sometimes you can have more than one, maybe 4, and here you can determine which GPU you want to use for training neural network. So
sorry, Professor.
Yeah.
How can I change it to CPU? Where?
Runtime.
Yes.
And change runtime type. And
okay.
Here you can determine hardware accelerator, non-GPU, and there is another way, TPU,
yes.
but I can't use. Don't use it. But
Too
of
fast.
course you can try. So
okay.
Any questions, maybe? No.
Thank you.
Okay. So after this, we can determine the data. First of all, train data and test data from the MNIST data set. We download all data, all the data sets from the internet right here, and the first data will be train data. The second data will be test data or validation data, which not used for training, but of course we sometimes validate our models on this data. So let's run. You can see that everything is download. Maybe we just check that we download our data. You can see that we have folder MNIST, which contains all images, and here some folders processed and raw. Somewhere here contains images of the data set. And if you just put train data, you will get some information about data sets. This is data set NIST, number of data points 60,000, root location, and which subset is a train subset. So if we try to test data, we will get that this data is a test subset and contains 10,000 images here. I just show you that from the trained data using index, we can get information. First, it is a PIL image in some array, some array image with the size 28 on 288, and the second attributes means what means the number of this image. We can look on image, for example, like this. It is a free, and here the label means that this is a free number on image. Yeah. Here I just want to show you that always we need to analyze our data set. Yeah, and I use targets of trained data for getting information, for getting distribution of each numbers here. Yeah, and you can see that it is like a uniform distribution. Maybe sometimes it is a 0 value, it is a 1, 2, and etc. It is a 9. Yeah, 9. So just run, and we will get in what happens here. Okay, uniform distribution, like a gender, race, and age distribution. Before we start train our model, we need to check the distribution of all data, because if you will have just a 0 and there is no any ones, so you can't train your model recognize ones on images if there is no ones in your data set, of course. Yeah. So such pre-processing task it is very necessary for us. So now we have a data set, and after this data set, we need to determine some important information. Now let's look maybe like this. If we get some images, we can get two-dimensional array of this image, yeah, and it will be looks like this. But before starting training our neural network, we need to normalize this image. Normalize this image means we need to transform all values in a range between -1 to 1. For this task, we determine some transformation which allow you, first of all, change an NumPy array into tensor, because PyTorch work with tensors. We can't use any NumPy arrays and other arrays, only tensors from PyTorch. You can see that transforms. It is a sub-library from Torch Vision which allows us transform any data into tensors. So and if we again reinitialize our trained data, and after this we can get information about trained data. Here we show shape. Torch tensor, it is a 1, means just one channel of it is like a grayscale image, and height and width here. Yeah. So I guess it is some features of PyTorch that the channels stay before height and width, but commonly channels stay after all, means high, width, and channel. Yeah, but in PyTorch, you should determine the channel before. If you have RGB image, so here should be free, not 1, should be free, because free channel. So of course, sorry. Image shape 1, 28 and 28. So, but if you want to show your image using PLT, you need to remove this one, because such function don't understand what doesn't mean 1 before height and width for grayscale image. If you have RGB image, you need to change the position of channels and put the channels after height and width, means 28, 28, and 3. And this function and show can work correctly here. Yeah. So here we can determine PLT color bar for better understanding. You can see that all images lie in range from -1 to 1. Yeah. So using such transformation, first of all, we transform all images into tensor, and after tensor transformation, we normalize through the median and standard deviation, and we will get such examples in such images from -1 to 1. Normalization, it is necessary for converge neural networks. So of course you can try to train your model with images from range from 0 to 255. Yeah, but it is not a good way. Maybe you can converge your neural network better if you normalize all images. So now we have train data and test data, and after this we need to determine data loader, which used for training and validation our neural network, and we create some things, yeah, some things like loader, train loader, and test loader, because test data consists all images and train data consists of all images with transformation to tensor and normalization. Data loader allow you to get small portion of your data. Means you put your train data and get some small part of them, which is called batch. And here we use attribute shuffle before we start loading small parts of data. We will shuffle them. So now we can determine train loader and test loader, which can be used in a loop. On each loop we will get some small portion. For instance, like this. If we get test loader, we can get information about our data. You can see that small portion of our data consists of 64 instances or maybe images. So with one channel and height 28 and width 28. And torch size, it is a target variable, means 64 target values. This is a target. It means that you have a corresponding, for each images you have corresponds values about these images. What does mean? Images, it is a 7, yeah, and in targets we will have the 7, yeah. This is a 7. For example, for each images we will get target variables here, yeah. So, and of course we can show some examples. Yeah, we just get images from example data and apply the title of each images from target variables, and you can see that 4, 4, 2, 1, 8, 8, and 8 here. Yeah. Now we can start with our convolutional neural network, and previously Hoon told us about convolutional neural network and LINNET and etc. So we just get some simple convolutional neural network which consists of 2 convolutional layers with kernel size 5 and 2 layers with max pool. And after this we can use linear layers which allow us to classify. First of all, this part, it is a feature extractor, means that we convolute our images convolutional neural networks and max pooling, and after this we use linear layers for classification. Means we use features for classificate digits, handwritten digits. In PyTorch, we need to create such class. First, init, we just init all layers, and in methods forward, we need to connect all layers, connect all layers here, And you can see that X means input image, and we put this image into first convolutional layer, first convolutional layer. After this, we apply max pooling operation for this image, and after this, we apply activation layers, and we will get some tensor, which consists of 10 feature maps. Here we can see that input number of channels for input 1, number of channels for output equal 10. Max pool 2 means that we decrease the size of all feature maps into 2 times. The next operation means that we will input 10 feature maps from the convolutional neural network 1 and max pooling 1, and we process them into 20 convolutional neural 20 feature maps with kernel size 5. For better understanding, we can discuss this idea that we have layers, and there is output shapes, means that first convolutional layer transform images. Okay, let's write something like this. Input shape. Just determine 1, 28, and 28. After convolve these images with 10 filters, we will get 10 feature maps, but the size of this picture decrease. I guess that these details we will discuss on my course. Yes. Now we just I just want that you understand this, the main idea. So we have convolutional layer and transform these images into these images with 10 channels, and after this we apply max pooling operation, and we decreased the size of the image into 2 times, and convolve this tensor using the next convolutional layer, and we will get new tensor with 20 feature maps with size 8 by 8. And after using the second max pooling operation, we will get the same 20 feature maps, but the size will be decreased on 2 times here. So this tensor describes our picture, and if we multiply 20 by 4 and by 4, we will get 320. And these values, 320, we can just flat like a one-dimensional array, 1D array, and using fully connected layers represent as a 51-dimensional layer. And after this, we can use the second fully connected layer for represent 50 features into 10 features, because we need to classificate just 10 digits. So the last layer, last linear layer, has 10 output, which show us the probability to classificate, for example, any digits, from 0 to 9, just 10 digits. So let's run Now we have this model. Sorry, what happened? Using torch summary, you can check that everything is correct in your neural network. For example, of course, you can put into your neural network other picture with the different size. For example, 38 and 38. Yeah, but here you will have some problems with shape because you create the model. You create the model using convolutional neural network, and after the last max pooling, you need to determine the value input size. Yeah, input size here 320. Yeah, and if you change the layer, you can get the same number of features, and so you need to change your architecture, and using summary, you just check that everything is correct and everything works well. So the next thing, it is a training model, and for training model we need to determine some important things. It is first, it is a number of epoch, and log interval means we just show information about training our neural network after 200 iteration here. Yeah, so maybe we just run it, and I will get some comment about how we can train. So we determine again our neural network and put our neural network into GPU devices, and of course we need to determine optimizer of weights of convolutional and fully connected layer, because in our models only convolutional layer and fully connected layer has a weight which can be changed. So using optimizer, we can change the parameters of our neural network, and here we determine learning rate and momentum, which is impact on training our neural network. But of course, the detailed information will be on my course. Yeah, but now we just look at train. We determine function train, and here you can see that we change the status of our neural network into train. It means that we can change the weight of layers, and here we run the loop using train loader, and from the train loader we get data. It is images and target variables, which is show us about the numbers, numbers on images. We determine that all gradients in our neural network equal zero. We put our images with handwritten digits into devices. We put our target variables about images into devices, and we use data for predicting by neural network. You can see that neural network, we put the data and get output information about this data. On the first iteration, this output will be worse, but how we can train our neural network? We compare output of neural network with target variable using NNL loss, and this loss show us the error of our neural network and the real values, target variables here. Yeah. And after this, we try to decrease loss function. Means if the loss equals 0, means that neural network show us the right answers. Yeah, the right answers. And using method backwards, we can calculate gradients through the whole model, through the whole convolutional model. And using method step, we can change the weights of all layers. And after the step, network should work better than previous step, because we decrease the loss function, means decrease the error of network. And after the stepping, neural network should work better. And using such steps through the whole data, we just change the weights of neural networks on each step, and such way just allow us to train model. So there is some conditional which show us information about train epoch, and the next step, it is the test step, where we determine where we change the stage of our network into evaluation. Means we not train this model, just evaluate, or inference model. And here we just calculate the loss function and predicting means it means output of our neural network, and we calculate the correct answers here. Yeah. So, and some information about training. So let's run, and here we just run the test. Run the training. Here you can see that we train epoch 1. Okay, so I guess that this is the first test set. Average, we can see the loss function we equal 2 and 3. It doesn't matter what does it mean, but you can see that accuracy equal just 11%. But after training, you can see that the loss function is decreased. And for training data sets, sorry, not training, we need to see test data sets. After first epoch, the accuracy will be 81%, and loss function decrease. After the second epoch, the accuracy will be 91% here, yeah, and loss function decrease too, and etc. So we just determine just a 5 epoch, and after the after training, you can see that our neural network will achieve maybe 25%, and one moment. Will achieve 96%. You can see that this is the number of correct answers from all test data sets. I just remind you that 10,000 images in test data sets here. Yeah. So the loss function corresponding to accuracy. Yeah. And here we can plot the curve of training our neural network, and you can see that the loss function is decreased, and of course the accuracy increased higher and higher. So this way you can apply for training, for example, using space for age classification, or sorry, for gender classification. So and the last important thing, inference model. Now we train our model, and we want to use it for predicting some classes. Okay, let's run. For example, I get test data with index 55 and get some images and target variable. You can see that this is a 0, and for predicting values of this, I need to first of all I need to change this NumPy array image into tensor like this, yeah, torch tensor. After this, you can see that image shape equal 1 by 28 by 28. We need to add some additional dimensional on the first position here. Means your shape should be look like this 1 1 28 28 because convolutional neural network using such tensors. Of course, this is the batch size, and it doesn't matter which batch size you want to use, 1 or 64 or maybe 1000. It doesn't matter. But here it is just some rules for neural network here, yeah. And after unsqueezing, just add once in the first position in your tensor here, dim 0. After this, you change the stage of your neural network into evaluation, and you put your input image into this neural network, and you will get output. Output tensor look like this, and for classification, you need to get index of maximum elements from these values. It means where the maximum value elements here, so it means that this is a class of this image. So here you can see that the biggest elements equal 0, this one, because it is a closure to 0, and the other elements is negative values. It should be noted that output it is a tensor like this, and these tensors lies in GPU, and before processing this tensor, you need to put these tensors into CPU using method CPU. After this, you should detach this method and transform into NumPy array. Yeah, it is a complex syntaxis, yeah, but it is necessary for changing into NumPy array. For example, if you try to use like this, just NumPy array, yeah, you will get errors here because you use tensor CPU to copy tensor to host memory first. Yeah, for example, if you try to CPU here, you will get the next problem that you need to detach your tensor, and here CPU detach. But runtime error and some warnings allow you to fast change your code and to make your code correctly work. And here you find index with maximum elements, and it will be 0. Okay, we can just get another image, for example 5 here. Put our image into neural network, and we will get the argmax 5 here. The same things will be working for face recognition, for gender classification, but of course you will get only 0 or 1 because you just have only 2 binary logical here. Yeah. So I attach this this notebook into Teams. Your task will be try to implement face recognition to neural network. Maybe it will be better if you change all faces which you process faces to size 28 by 28, and you will need to change some information in neural networks. For example, here you should write 3, and log softmax here you will need to just 2 because you have only 2 genders, yeah, male or female, and faces it is RGB images, and they have just a 3 channels. So maybe if you have any, if you will get, sorry, if you will have any questions, you can ask.
Dear students, do you understand your task?
Of course, previously you need to conduct analysis UTK data, UTK faces as Ali, yeah.
Yes.
Do you have any questions?
Of course, you should try to run this code, and after this you can try to change it. Maybe change it for the task of gender classification. Okay.
Okay. I think you should try try to implement this code, and I think we will discuss it next week. Okay.
Yeah. I need to rerun it.
Professor, excuse me. Now, what is required in the old task?
Required, you mean that the task, first of all, you need to implement the UTK databases. Yeah, you process the face, and you need to change the size of all faces to size 28 by 28. And using this convolutional neural network, you can put, instead of digits, just the faces. Yeah, just the faces, but 3-channel faces. And I guess that this code should work well for this task, and you should train your train model for gender classification here. Yeah. So if you will have any problems, I guess that we can discuss on the next week. But of course, I think that you should try to do this, and send me some questions or ask some questions on the next week, and we try to implement.
Sorry, Professor. Can you write?
Right. Okay.
Point the task.
Yes, of course. I write.
What is required?
Okay.
Thank you.
Thank you too.
Okay. Okay. I think you should start, and you can find some questions to this task, and I think we will discuss. Please, Mohammed, you should to get ready to next lesson. Okay. Mohammed, do you hear us? Hello. Okay, and if you don't have any question, I think all for today. Thank you. Goodbye.
Thank you,
Yes,
Professor.
thank you, Professor.
Goodbye.
Goodbye, Professor. Yeah, goodbye.